Hey, what's up everybody? Welcome back to 3D Thursday. I'm Noe Pedro Ruiz, a designer here at Adafruit.
Hey everybody, welcome back. I'm Pedro Ruiz, a creative technologist here at Adafruit. Every week we come to share 3D printing stories, projects, and techniques. Noah, what do we got on this lovely show for this week?
Yeah, sure. Let's take a look at the segments. We got, what are you prototyping?
That's right, so we take a look at behind the scenes of some of our upcoming future projects.
Very cool. We got some 3D news.
Every week we scour the net for interesting stories happening in the world of 3D printing.
Then we'll take a look at our weekly video.
That's right, this week we have a cool review of the Type A Machine Series 1 3D printer.
Oh yeah, and then we'll take a look at the layer by layer segment.
That's right, so we're going to check out the printing profiles and some of the settings we use for our new, very cool machine.
That's right. And we got some special for you guys. Every week we got
coupon code. That's right, you can get 10% off discount on any 3D printing accessories or electronic goodies for your future project. Just use the discount code Type A, you can get 10% off. Expires at 11:59 p.m. tonight. Doesn't work on software or gift certificates.
Yeah. So let's go ahead and jump into the prototyping segment. Pedro, you've been working on some very cool projects with the Amber printer.
That's right.
The Ember printer from
So
Autodesk.
the Ember is the DLP SLA 3D printer, and it is excellent for printing small enclosures for one of our, a lot of our small electronic projects. So this is the bone conductor project that you worked on, Noe.
Yeah.
All of the components fit in there quite nicely. The tolerances are really good. I really like the way it looks like an extruded piece of acrylic. So the snap together parts fit really good, and this was a test on seeing if we could print objects with no supports. So this was printed flat on the bed, and there's very little deformation on it. You see just a little bit of the corners where I had to pry it off with the spatula. But other than that, you can see some scratches that come out there from putting all the electronics in there. But otherwise, it looks pretty good. Really happy with the transparency of the clear material. And then we also got a very cool request from Colin. Very cool, what is it? Cherry Blue MX keyboard, and we're going to be making some custom keyboard keys for that.
Yeah, show us real quick the detail on that. Looks really cool.
Yeah, so this is printed at 50 microns. Actually, no, this is printed at 25 microns.
Oh wow!
You can see the detail on this. You can kind of see that there's some fangs on this here skeleton.
Yeah, it's a nice little skull there. Is that the escape key, I think?
This is going to be for the escape key. I'm going to update my modifier buttons and as well as the window button here. So this is a really cool keyboard. I'm sure a lot of you cool programmers out there have this very cool model. Check it out, I got a model that goes between green and blue.
So this is going to be really cool, especially for the people who have this keyboard or maybe thinking about getting the keyboard and 3D printing. This is a really good combination of both.
Yeah, it's excellent because it's able to print small little details like this here while still maintaining strength.
Yeah, the great first project.
It's gonna be cool. And you've been working on a very cool trophy for an upcoming festival.
So we were sharing a little bit of the prototyping last week. This is the finalized trophy. So it is printed in bronze fill. This is a metal filament from Color Fab, and we put together a cool video that will be coming out in the coming weeks. And be sure to check out Adafruit's blog and social channels for more details on the Droney Film Festival and Award event. Very cool stuff there. Oh, look at that little Droney. Is detachable from.
Oh yeah,
from
Amber prints.
Yeah, and
we'll cover this in a future episode.
Yeah, we'll talk more about all the pieces and stuff in that episode. So, we got some 3D news.
Let's dive into the world of some 3D printing news.
All right, first up, we got some educational resources for you guys. So this is a tutorial on Fusion 360, and this is by Tyler Steen.
Tyler Steen of Autodesk. So he takes you through some of the steps on importing some EagleCAD files, extruding all the components to make an Arduino enclosure.
Yeah, so this is really cool if you're looking for a CAD package for solid modeling that's really, really robust. This is definitely the way to go with Fusion 360. It used to be Inventor, and then it turned into Fusion. Now it's Fusion 360. Very, very cool features. I really like the way that you're able to modify
Can you skip to it,
history.
Yeah,
sure. Check it out.
Some really cool things on moving your timeline history around. So he actually goes forward in time, grabs something, then moves it back to a previous sort of step in time.
And then brings it forward, yeah.
So that's pretty freaking cool.
Yeah, it's pretty mind-blowing stuff, yeah. It's really good for sort of smart, non-destructive editing as well. So you got a lot of cool features there.
And you were saying that you can actually have your voids be at one same spot. You can scale everything around it, and they still maintains all the same sizes.
Yeah, you can change your thickness and then keep all your holes exactly where they need to be. So it's really cool. We're definitely excited to use Fusion 360. So thank you, Tyler. He's definitely going to be coming out with more tutorials. And I really like this one because it's not like a sped up, like a sped up time lapse. So
it's like about a half hour.
It is about a half hour full on the design process and what the problems that he has. He even has a cool little mistake counter at the bottom. But it's funny because he uses that to leverage all the cool features. So very, very cool there. Definitely check it out. We got a link for you guys in the description, and it's on the blog. So check that out.
Next up, pretty popular story that's making the rounds.
Oh my God, this just got featured on Thingiverse. This is a massive project. I'm sure you've seen our DIY Game Boy. Well, this takes it to a very cool themed Adventure Time theme. This is BMO from Adventure Time, and it is using a Raspberry Pi A+. It's using RetroPie to emulate the games. Some custom PCBs perf boards to get the buttons going. And it's a very, very cool looking project.
That's right, he has a Google spreadsheet of all the build materials if you want to go ahead and make your own. A gallery full of a ton of photos. It takes you all through the step-by-step of putting this whole thing together. And files are of course available on Thingiverse for free, so you can build your own. And
very cool.
A nice mix of different types of components.
Yeah, some Adafruit parts. We got some parts from SparkFun and various other places. Very, very, very big build. Very cool. I really like how the enclosure was designed. This thing is really, really cool.
Yeah, I like how the built-in speakers are set up just how BMO is.
Exactly, yeah, exactly how it is. Yeah. So that's a really big project. Again, you can check it out on Thingiverse. There's a link for you guys in the description. And then next up, we got another tutorial.
Seems to be Tutorial Thursday.
Yeah, right.
So this one is a really cool one using Blender, and it shows you how to model some chess pieces. It takes you through some of the steps on extruding, workflow,
subdividing.
It's also more of a navigating through Blender itself. So really good 101 tutorial on how to navigate through the interface.
Yeah, and creating a really cool, definitely like a first-time project for 3D printing, especially a chess piece like this doesn't require support material. So I like that. So you can check that out on YouTube. We got a link for you guys in the description as well.
Yeah, so this is by Jonathan Williams of CG Cookie, and he made this for iMaterialize, actually.
Oh, okay, so a little partnership deal. Very cool. All right, and then up next, it's pretty cool.
So this is a cool little articulating figurine robot from, it's the BQ mascot robot. So BQ is the maker of the Whipbox, who also supports Octoprint, Gina.
Yeah, I think she works with them. Yeah, very cool.
So this is a very cool step-by-step, sort of like a Eurista video of sped up of all the steps that you need to take. To build the whole, after the post-processing, really, after you get done printing.
In assembly, very important, yeah. So it's a very crafty type of project. A lot of different materials here to make the fits nicely fit into place. It's very articulate. And I like how it's pretty much like an artist mannequin, right? So it uses some elastic string and some wire to thread it through the parts. That's a really cool approach to making a doll like this, and it's fully posable.
I really like how it was completely thought out for having materials on the inside to hold it all together. You can definitely add some LEDs or some more electronics into there too.
Yeah, very cool project. And you can check it out. It's for free on Thingiverse. You can download it now. We got a link for you guys in the description.
Yeah, this is really cool. This is actually modeled by the Innovation and Robotics Department of BQ.
Okay, right on.
Very cool initiatives that they are taking here.
Okay. And
next up, we have
robot arm.
Robot arms.
Very cool.
So this is by Andreas. It's a fully 3D printable arm project that he's been working on, and he has it moving a glass of water, which is pretty, you'd be pretty confident.
Oh yeah, it's right.
In your design, if you're moving around water around electronics. So pretty cool. Little jittery here, but he's still working on all the algorithms for that. But it's really cool. He's controlling it with a gamepad there.
Yeah, here's the gamepad. Very cool. And I like this. This is a part 9, and he goes through like, here's what I need. Of course, I need to make an enclosure. So he actually goes through some CAD and shows us how he put together his enclosure. And it's not 3D printed. It's actually laser cut and using metal extrusion.
Yeah. And so he takes you on a tour of his local fab lab there, and he's using laser cut just so he could speed up production on this.
Oh yeah. totally the
Very
way to
cool.
go. Yeah. So very cool. If you want to find out more about the progress on this project, I've got a link for you guys in the description. You can check it out.
Check out his YouTube for more progress.
Very cool.
And then
lastly, we have more of an easier project. This is pretty cool. Pedro, what is this?
So this is find my notes here. This is a 3D printed leather stamps.
Oh, okay. There you go. Wow, there's a lot of detail on this. How was this printed?
Yeah, so this was made inside of Fusion 360, and this is an instructable that takes you through making seamless patterns inside of Fusion 360.
Oh.
And then he's using an object printer to print all these little guys out. And a lot of the tools you need are, stuff you can find around the house for making your own leather patterns.
Oh, it's really cool. I like using 3D printing to sort of be a tool for other materials instead of the print itself being the material. And this is really fine detail. Look at that. I really like how it's a circuit. Very cool.
Very cool theme there. Yeah, so he's using, like a mallet, quartz slab, water, sponge.
Oh, okay, yeah.
He's just stomping that in there. And the extrusion widths that he said that it found were really good for that were about 2 millimeters extruded outwards to get those patterns to really show up on the leather.
Yeah, they look really awesome. Okay. So I think that's going to do it for the news, guys. And don't forget, we got a coupon code for you guys.
10% off. Use the discount code Type A. Expires at 11:59 p.m. Doesn't work on software or certificates, but of course you can get a load of 3D printed accessories and electronic goodies for your next project.
Oh yeah, and speaking of the Type A machine, all right, that's today's video, Type A machine.
All right, so the Type A machine is open source, made out of all aluminum CNC folded parts. It's got a ginormous build plate of a 305, 305, 305, or 12 by 12 by 12. It is our new favorite 3D printer.
Yeah, totally. The build plate is, like you were saying, it's really, really big. It is a glass build plate that's fixed to aluminum, and it's actually removable too. That's really nice if you want to really get into your parts and break them off the build plate. You can do that. And if you ever have a printer that has a really large build plate, you'll know that it's actually really hard to level because it's pretty big. So this has like some really nice thumb screws and a really nice setup for leveling each corner precisely. There's also a nice little big knob in the back for adjusting the Z height, and there's even a little graphic on the side to let you know which way to turn the knob when you're leveling the thing.
This is pretty revolutionary there. Just having a knob that adjusts your Z height and a graphic to tell you which way is tighter or looser on the bed.
Yeah.
We're not very big fans of the auto leveling procedures, that the Lowesbot Mini has or the PrinterBot has, because the Z probe and
it can be problematic sometimes.
It can be problematic, yeah, and it's so frustrating when a print starts and that all you have to do is move a corner down by half a millimeter, and it doesn't allow you to because it's all auto sensing.
Yeah.
So that's a very big pain in the butt when you have a needle just crash down into your build plate, when a minute ago you just had a perfect leveled plate that had a successful print, and now all of a sudden it's completely unleveled.
Yeah. So yeah, there's a little trade-off there, but this machine has a really good way to level it with the bed plate and the thumb screws. And then really what comes down to is a really good nozzle and extruder, and we really like the nozzle and extruder design. This is the Winchester version 2, I believe. And this thing is definitely different than any nozzle that we've seen before. And because it's so small, it actually heats up in like 30 seconds. It'll go from 0 to 220, which is amazing.
Actually 230 in 30 seconds, yeah. Because it has that, they call it the needle nose extruder.
Very cool.
It's so fast that, it has a very small heat zone around it. Like when you're printing a lot of objects, that sort of heat sort of builds up around a certain area. And if you have like a ginormous nozzle, that's going to increase even more. So this has a nice little small, sort of area of heat.
And speaking of heat, this thing can go up to 270C.
275 actually, yeah.
Okay.
So they have the widest profiles that I've ever seen for any 3D printer. They've tested things I've never even heard of, like
that's right, like magnetic stuff, some steel,
some iron. They have
PLA
like
Plus,
PLA Platinum, IGUS. They have a ton of materials that they've been testing on this, and they have all the profiles up. And of course, our favorite material works right out of the box here. There's no modifications that we need. It has a pinch wheel, so you can print Ninja Flex, Semi-Flex perfectly. It also has a very comfortable spring-loaded
direct drive system going on here, so it definitely works with most of your filaments.
And this is where all the magic is happening here when you open this guy up, pause it there. And this is the single melt path that makes, you know, the printing so precision. So if you take a look at some of the other extruders, like say, you know, the Lulzbot here, look at how big this is. Look at the enormous area of melt that you have to go through. And just, I mean, the size of, you know, the extruder here compared to that. I mean, there's so many points of failure for this. When you gotta, you know, take this apart and a clog happens, I have to completely disassemble this whole thing. And there's like a mixture of parts in here. There's like plastic and wood and like the resistor that always blows on you. This thing is completely all metal. Like I said, a single melt point. So when you're doing like a color change, the color changes immediately.
Oh, so no, that's right, no gradation?
There's no gradation, yeah. There's a ginormous chamber in here where the filament just fills up and sort of just mixes with everything else.
Yeah. Okay.
So they've really figured out their extruder designs there.
Yeah, very cool.
So this is probably the best way to make an extruder design.
Okay.
And it's also running on linear guide system. So this is precision milled. It's got really good bearings for everything. And the thing sounds like, you know,
futuristic, because it's got micro steppers. That's right.
I just love the way this thing sounds when it starts up and when it's grown. It's got that very nice like servo sound, not like, you know, like a belt moving or a rod like, you know, squeaking as it's moving up.
Yeah, the noise is just elegant. And one of the most coolest things that we like about it is the start G code. So this is when this is the thing that happens right before print. So what it does is it actually goes beyond the build plate, starts purging, and then it performs like a sort of a wipe nozzle thing. So that's a really, really nice thing. So you're going to know that your prints are clean. They don't have that anchor that they have to worry about.
This definitely makes the Lulzbot Mini wipe sequence look like a joke, because this is the only printer that we can sort of set, walk away, and know with confidence that there's not going to be this giant blob of, you know, purged filament that's left over on the print.
Yeah.
They've really figured out how to do that.
Very cool. Let's take a
and
look
of course,
at the
this is completely open source. We have a BugleBone Black in here that's running Octopi. Octoprint. So Wi-Fi is already included. It gives you access to all of your stepper drivers here, so you can adjust the current. They give you access to the power here, so if you wanted to upgrade your bed to a heated bed. They have USB ports. You can add a camera. You can even power other Pis for other cameras. And this thing is, you know, it looks like an Apple 3D printer without, you know, sort of the proprietary Apple, you know, mindset behind it. It's completely open source. They give away all the drawing files, all the build of materials. This thing is phenomenal for just ginormous prints. The support materials that come out of this are superb. Nothing sticks to the, you know, to the actual print itself. You're able to just flick a lot of the prints off, and a lot of the, you know, this is perfect for cosplay, for props. As we were saying, the support material that comes off of this. If you pause this here, right about there. So this is our Daft Punk helmet. The Tazbot was our, you know, biggest printer before this, and you know, the helmet is as big as we can print. Now we've heard a lot of complaints on the, you know, sort of the shape.
It's a little bit shorter than it should be. It cuts your chin off
and that's, you know, that was because of size limitations. And if you take a look at the video here, you can just see how much more we're able to print. So I could definitely redo this and have the proper shape for the helmet. Yeah. And it might be able to, you know,
some room to spare.
Some room to spare, yeah, be able to fit people with bigger heads. So this is, you know, you can just see the size difference here. You know, printed, you know, like, there's like almost 60 millimeters higher than the Taz.
Here's another print that's like very, very tall. It really takes advantage of the full bed.
Yeah, and again, with the link claw shot that we printed out here, we just wanted to, you know, make it as big as we can. And you can see that, yeah, the Z height is just enormous.
Very big prints. We've been printing so many large things. That's pretty much the first projects that we threw at it. Is like, that's, you know.
But not only just big prints, small prints, because of the precision of that awesome little small needle nose, you know, extruder.
Okay.
It's able to print really small details down to 50 microns. Works excellent.
Let's take a look now at layer by layer segment. We'll take a look at some of the slice settings that we have set up here in Simplify 3D.
Yeah, so they give away a lot of the profiles for Cura. They actually have their own branded version of Cura that'll connect right to it. So you can get a lot of these settings. You can get it off their website or learn.adafruit.com. Yep. We also give away the Simplify 3D one just because of the support structures that we need to generate for a lot of our projects. So let's go ahead and walk through some of the settings that we have.
Yeah, sure. So
a lot of these are actually default settings that come with Simplify 3D. So this came with the profile for it already in there.
Right on.
So to start off, we're going to look at our nozzle diameter, and this is actually the default. It's at 3.5, and the extrusion width we have set to 0.42, and this is to sort of do the thin wall trick where it doesn't do any jitter width inside the wall. It'll just add an extra line to extrude inside of there.
Yeah, so we tend to leave the setting since we're doing mostly enclosure projects. So yeah, this works out really well.
The retraction settings, again, Simplify 3D figured this one out, and it's set to 0.5, which works pretty good. There's no goops, and we can show comparison shots of printing different parts on different machines and just how goopy it is on a different machine compared to the Type A.
How about retraction speed?
Retraction speed here is set to 40 millimeters a second. And a cool thing here that they've figured out the settings for is the extra restart distance, which means that as it retracts, it doesn't have enough filament to push back down out. So it'll restart, on the model, negative 0.05. So it has, so by the time it goes over that 0.05, it's already extruding filament.
Okay, very cool. Now how about the layer height?
So the default that we have our layer height set to is 150 microns, and that works excellent, especially when you have organic shapes that are sort of going off like that. You don't see like this giant, separation between the layers. It nicely, fills the gap in between for all those.
Yeah, very cool. Well,
so the top layer, bottom layer, you were printing some copper fill and Ninja Flex, so that's why these are bumped up so high.
Oh yeah. Yeah, 5 and 6 tend to work really well, especially with copper fill and Ninja Flex. The Droney Trophy actually needed to bump it up from 3 to 6 just to give it that extra bit. And I also increased the shell count here so that so that it could withstand hours of tumbling, because that's what you're going to do with these parts, especially with bronze fill. You can throw it in a tumbler. You want to have a nice thick layer height. Okay. Anything else here? Maybe first layer?
So the first layer height we usually change for, I think, semi-flex and Ninja Flex. We usually want to have it down to either 80 or 90%, which will make it squish down into the bed a little bit more.
Oh, okay. So less is more squishy, okay.
Yeah, so the extrusion layer width also we have at 110. I believe that was a default there.
Okay.
And then for first layer speed, so since we don't want it to go so fast, we want it to be able to, squish in there, make sure that that enough material extrudes out so the subsequent layers can stick to something.
Yep. We
have it go a little bit slower, so we have it go at 80% of the speed down there.
Okay. And then how about some infill?
Infill just varies. For Ninja Flex, Semi-Flex, we tend to do it around 15 to 30%, just so there's enough material for all the layers to stick to. For regular PLA prints, we usually go around 8% to 10%. Yeah. And things like the gun blade, I think I printed at 8%, and I gave it, that was plenty for it, and it, makes it lightweight, while still maintaining a lot of strength.
Very good.
And the strength is coming from, well, actually I'll talk about it after this one. It's the outline overlap. This, because of the diameter set to 3.4, we're to make sure that the outlines and the infills are able to touch, and they're, because of the thinness of it, we want to increase that up to 25%. I think the default is 15% on it.
Okay.
And then the infill percentage, or the infill extrusion width, because it's traveling so fast, it can go up to like 250 milliseconds, millimeters a second. Yeah. You want to make sure that it extrudes a little bit faster when it's doing the infill, so it doesn't come out all stringy or, without missing any steps. So we want to increase that to 200%. Either 150 to 200% for that.
Cool. Temperature?
Temperature seems to be that a lot of the different materials seem to print really good at 230 degrees.
Yeah.
So we had some questions on the semi-flex, and 230 degrees seems to work really good.
Right on. Okay. And then G-code, or actually scripts.
Scripts.
Sorry.
Something's pushing, yeah.
Yeah.
Okay, so the script, this is where the awesome purge generation happens. And the script, so you can just sort of read through here of where it happens. We wish a lot of the printing manufacturers would actually use this. Yeah, please take note and use this purging technique. I love the way that this works.
Yeah, I think it's a little bit a part of the design too, because the extruder itself can go beyond the bed, and a lot of the printers can't do that. And I think being able to do that is what allows you to do edge-to-edge printing, and of course this nice little wipe nozzle feature. It's very cool. And then other, this is where all the print setting stuff is. You want to talk a little bit about
print
this?
speed, yeah. So now we have it set to 40 millimeters a second. That's because you were using Ninja Flex, I believe. So 30 to 40 millimeters a second is what gets you optimal results for that with a really nice surface finish. For standard printing, like PLA, we tend to bump it up to 60, 80, and 90 millimeters a second, just depending on how complex your
part is, yeah.
Parts are. If there's support structures where you need to go a little bit slower and make sure it doesn't knock anything over. And that's pretty much all the settings. You can get these exact same numbers inside of Cura. And again, they give you profiles for a ton of different materials. You definitely want to check that out.
Right on. Okay. Well, I think that's going to be the show, guys. We'll leave you guys with a couple of cool links for you guys to check out. Again, you want to check out the Adafruit Learning System. We always have cool projects. All of our projects live up there. You can check yourself out there. And then,
if you want to get the profiles for this and any of the printers that we have in the store, check out the buyer's guide, or what is it, 3D printer buyer's guide from Adafruit. It's on learn.adafruit.com. Just search for that, and inside there are profiles for every printer that we sell in the shop.
That's right. We share them on GitHub. Very cool. And then if you want to share some projects with us, be sure to check out the Show and Tell show that's on every Wednesday at 7:30 p.m. Eastern Time. You can check that out. We also have some cool posts for you guys on our Google Plus profile. 3D Thursday.
Every Thursday, we have a ton of postings. Put everything up there. Just search 3D Thursday tag. And of course, we're on Twitter, Instagram, and Thingiverse. Follow us. You can follow VideoPixel, myself, or Noe, which is Ekin. And of course, Adafruit for all the behind the scenes, any upcoming projects that we're working on.
Yeah, and don't forget, 10% off discount.
That's right. Use the code Type A. It's going to expire tonight at 11:59. Doesn't work on software or gift certificates, but you can of course get a lot of awesome, 3D printing accessories, printers. Pick up a Type A and follow along with a lot of projects that we're going to be working on with it.
Yeah, very cool. All right, guys. Well, that's the show. Thank you so much for watching. And be sure to check us out next week where we'll have some very cool stuff. And yeah, we'll see you guys next week.
See you guys.
Bye. Bye, everybody.